Welcome to the 15th lecture on quantum mechanics. We continue the problems on uncertainty principle. Problem continues. The principle is uncertainty principle. Problem number 7. Compare the uncertainties in velocity of an electron and a proton confined in a 10 angstrom box. ഒരു 10 ആങ്സ്ട്രോം ഡയമെൻഷനുള്ള ബോക്സിനകത്ത് ഇലക്ട്രോണും പ്രോട്ടോണും ഇരുന്നാൽ അവയുടെ വെലോസിറ്റിയിലെ അൺസർട്ടനിറ്റി കമ്പയർ ചെയ്യുക. കമ്പയർ the uncertainties in velocity of an electron and a proton confined in a 10 angstrom box. So using the method, solution, delta x into delta p is equal to h. You can write h. When we do problem, the order we change into equal sign. That is delta p is h by delta x. For electron delta p, that is delta mv1 electron, small m is the mass of electron, is equal to h by delta x1. Delta x1 is the uncertainty for electron, and that equation we mark as 1. For proton, delta mv2, capital M is the mass of proton, h by delta x2, equation number 2, 1 by 2. We get delta mv1 by delta capital mv2 is equal to h by delta x1 by all by h by delta x2 is equal to delta x2 by delta x1 because h cancels. You put the you repeat the step. M delta v1 by capital M delta v2 is equal to delta x2 by delta x1. Therefore, delta v1 by delta v2, cross multiply, delta x2 by delta x1 into capital M by small m. Capital M, 1.67 into 10 raised to minus 24 kilogram. 1.67 into 10 raised to minus 27. 27, you correct it as 27. Proton mass is 1.67 into 10 raised to minus 27 by electron mass 9.1 into 10 raised to minus 31. The proton mass you have to correct 1.6 into 10 raised to minus 27 by 9.1 into 10 raised to minus 31. It is equal to 1835.16. Here delta x1 equal to delta x2 is given in the question. You read the question. Compare the uncertainties in velocity of an electron and a proton confined in a 10 angstrom box. 10 angstrom is the uncertainty, and that is same for both electron and proton. That is why we cancel delta x1 and delta x2 in the final equation. So answer is proton mass by electron mass, which is equal to 1836, and here if we calculate we get 1835.16. That's the answer. Next problem. A particle is diffracted at a certain angle, and the uncertainty in the measurement of angle is 1 second of an angle, or we call it as 1 second of an arc. Estimate the error in the measurement of its angular momentum. Here in this problem, The angular displacement error is given, uncertainty is given. We have to find the angular momentum uncertainty and use the solution. The principle in terms of angular momentum and angular displacement is delta L into delta theta equal to h. Delta theta, 1 second of angle, and this 1 second of angle, we have to convert it into radian. So at first we convert it into minute, then into degree, and then into radian. That's 1 degree is, pi by 180 radian. So 1 by 60 into 1 by 60 into pi by 180 radian. 1 second of angle is equal to 1 by 60 into 1 by 60 into pi by 180 radian. Initially you convert it 1 second into minute, then you convert 1 minute into degree, and then you convert it into radian. This is the process. The answer for that calculation is 4.848 into 10 raised to minus 6 radian. Therefore, delta L, h by delta theta, h is 6.625 into 10 raised to minus 34. If you write 6.626, there is nothing wrong. 6.625 is an accepted value for h. By 4.848 into 10 raised to minus 6 is equal to 1.3665 into 10 raised to minus 28 joule second. Joule second is the unit of angular momentum. So that is the uncertainty in angular momentum. Next problem. Show that if the uncertainty in the location of a particle is equal to the de Broglie wavelength, then uncertainty in velocity is equal to velocity. That question you read carefully and try to understand. Show that if the uncertainty in the location of a particle is equal to de Broglie wavelength, ഒരു പാർട്ടിക്കിളിന്റെ അൺസർട്ടനിറ്റി, പൊസിഷൻ അൺസർട്ടനിറ്റി ഡി ബ്രോയി വേവ് ലെങ്തിന് തുല്യമാണെങ്കിൽ, then uncertainty in velocity is equal to velocity. അപ്പോൾ വെലോസിറ്റിയിലെ അൺസർട്ടനിറ്റി വെലോസിറ്റി തന്നെയാണ് തെളിയിക്കുക. ഒരു പാർട്ടിക്കിളിൻ്റെ പൊസിഷൻ കാണുന്നതിലെ അൺസർട്ടനിറ്റി ഡി ബ്രോയി വേവ് ലെങ്തിന് തുല്യമാണെങ്കിൽ ആ പാർട്ടിക്കിളിൻ്റെ വെലോസിറ്റിയിൽ അൺസർട്ടനിറ്റി വെലോസിറ്റി തന്നെയാണ് തെളിയിക്കുക. This is a book work. Show that if the uncertainty in the location of a particle is equal to the de Broglie wavelength, then uncertainty in wavelength is equal to velocity. Uncertainty in velocity is equal to velocity. You see the solution. Delta x and delta p is equal to h. Delta p is h by delta x, and given a delta x, uncertainty in position is lambda, de Broglie wavelength. So we write delta p is h by lambda. Delta p is delta mv or m into delta v, h by lambda. That is delta v is equal to h by m lambda. And m, lambda, it is the de Broglie wavelength, and that is h by p. So we put h by p in the place of lambda. We get the relation delta v is equal to hp by mh. And here h cancel, p is mv, m and m will cancel, we get velocity. So uncertainty in velocity delta v equal to v, that is velocity. That is the answer. Next problem. Estimate the velocity of neutrons needed for the study of neutron diffraction of crystal structures if the interatomic spacing in the crystal is of the order of 2 angstrom. Also estimate the kinetic energy of neutrons corresponding to this velocity. Estimate the velocity of neutrons needed for the study of neutron diffraction of crystal structures if the interatomic spacing in the crystal is of the order of 2 angstrom. Also estimate the kinetic energy of neutrons corresponding to this velocity. ഇപ്പോൾ വെലോസിറ്റി ഓഫ് ന്യൂട്രോൺസ് തന്നിരിക്കുകയാണ്. വെലോസിറ്റി ഓഫ് ന്യൂട്രോൺസ് കണ്ടുപിടിക്കാനാണ്. ഇന്റർഅറ്റോമിക് സ്പേസിംഗ് ഉണ്ട് 2 ആങ്സ്ട്രം. അതിന് കൂടെ നമുക്ക് കൈനറ്റിക് എനർജിയും കണ്ടുപിടിക്കണം. You read the problem. Delta x to delta p is equal to h. Delta p is h by delta x. Delta p is m into delta v. H by delta x is equal to 6.65 into 10 raised to minus 34 by 2 into 10 raised to minus 10. That is delta v is h by m into delta x. 6.625 into 10 raised to minus 34 by 1.672 into 10 raised to minus 27 into uncertainty in position. 2 into 10 raised to minus 10 equal to 1.981 into 10 raised to 3 meter per second. That's delta V. Next is energy. Kinetic energy is E is half mv square. Here the velocity is delta V. We have to take uncertainty in velocity. We have to find the energy corresponding to this uncertainty in velocity. So E is half m into delta V square equal to half into 1.672 into 10 raised to minus 27 into 1.981 into 10 raised to 3 square joule. The step is repeated in order to convert joule into EV. To convert joule into EV, we have to divide it by 1.6 into 10 raised to minus 90. The answer is EV. Answer is in EV. So E is equal to 2.05 into 10 raised to minus 2 EV. That is the answer. Next problem. Calculate the velocity of electrons needed for the study of electron diffraction of crystal structure if the interatomic spacing in the crystal is of the order of 2 angstrom. Also estimate the kinetic energy of electron corresponding to this velocity. This is a repetition problem. In the place of neutron, here it is given electron. We repeat the answer. Delta x and delta p is equal to h. Delta p is h by delta x. M delta v is h by delta x equal to 6.625 into 10 raised to minus 34 by 2 into 10 raised to minus 10. On calculation, we get delta v is equal to 3.64 into 10 raised to 6 meter per second. And now we calculate energy. E is half mv square is equal half m into delta v square. E is equal half into 9.1 into 10 raised to minus 31 into 3.64 into 10 raised to 6 square joule. Convert into EV by dividing it by 1.6 into 10 raised to minus 19. The answer is E is equal to 37.68 EV. Energy of electron corresponding to uncertainty in velocity. is equal to 37.68 eV. Next problem. A bullet of mass 0.03 kilogram is moving with a velocity of 500 meters per second. The speed is measured accurate to 0.02%. Calculate the uncertainty in X. Also comment on the result. അപ്പോൾ ബുള്ളറ്റ് മാസ് 0.03 കിലോഗ്രാം ആണ്. അത് പോകുന്ന വെലോസിറ്റി 500 മീറ്റർ പെർ സെക്കൻഡ്. നമ്മൾ സ്പീഡ് അളക്കുന്നത് 0.02% ആക്യുറസിയിലാണ് എങ്കിൽ അതിൻ്റെ പൊസിഷൻ അൺസർട്ടനിറ്റി ഡെൽറ്റ എക്സ് കാരണം ഈ റിസൾട്ടിനെ കുറിച്ച് ഒരു ചെറിയ കമൻറ്റ് എന്താണെന്ന് വെച്ചാൽ പറയുക. എ ബുള്ളറ്റ് ഓഫ് മാസ് 0.03 കിലോഗ്രാം ഈസ് മൂവിംഗ് വിത്ത് എ വെലോസിറ്റി of 500 meter per second. The speed is measured accurate to 0.02%. Calculate the uncertainty in X. Also comment on the result. You see the answer. Delta X into delta P is equal to H. Delta X equal to H by delta P equal to H by delta M delta V. 6.625 into 10 raised to minus 34 by 0.03 into 0.02 by 100 into 500. Here the percentage is converted into number by dividing it by 100 equal to 2.208 into 10 raised to minus 31 meter. Delta X is 2.208 into 10 raised to minus 31 meter. And you look at the comment. The position of bullet cannot be measured to an accuracy less than 2.208 into 10 raised to minus 31 meter. ബുള്ളറ്റിൻ്റെ പൊസിഷൻ 2.208 into 10 raised to minus 31. അതിൽ കുറവ് ദൂരത്തിൽ നമുക്ക് അളക്കാൻ പ്രയാസമുണ്ട്. അതാണ് കമൻറ്റ്. The position of bullet cannot be measured to an accuracy less than 2.208 into 10 raised to minus 31 meter. Next problem. If the position of a 5 keV electrons is located within 2 angstrom, what is the percentage uncertainty in momentum? It's a repetition problem. You see the answer once again. We have done this problem, similar problem. P is root of 2m E root of 2 into 9.1 into 10 raised to minus 31 into 5. Energy is 5 keV. So 5 into 10 raised to 3 into 1.6 into 10 raised to minus 19 joule. On calculation we get P is equal to 3.815 into 10 raised to minus 23 kilogram meter per second. Delta X into delta P equal to H. Therefore, delta P is H by delta X. 6.625 into 10 raised to minus 34 by 2 into 10 raised to minus 10 equal to 3.3125 into 10 raised to minus 24 kilogram meter per second. The percentage uncertainty in momentum. The calculation is like a percentage error. Delta P by P into 100% equal to 3.3125 into 10 raised to minus 24 by 3.815 into 10 raised to minus 23 into 100%. A P is coming here, that you have to remove. There is no P. Is equal to 8.68%. That is the answer. And with this, your problem, uncertainty principle based problems are over. Next, in the next class, we take the continuation of uncertainty principle. The problems, there are 13 problems, and one problem you can expect in the examination. In the next class, we take another topic. That is all. Thank you very much.